Okay, so this is some help for 3.1. We're going to go through and do a couple of different questions, starting with question number 8. I think is where I was going to start. Yeah. Question number 8. Suppose that in the picture that 1,100 joules of work are done, and that picture is just here with the lady with the suitcase. So we know that there's a force being applied this way, but the actual displacement is at a different angle. So we need to know that angle there. We know that it says that 1,100 joules of work are being done. The force is 30.0 newtons. That should tell us that we're talking 3 sig figs. And we know that the displacement, or distance traveled, is 50.0 meters. And we're told that the work is 1,100 joules. Now we know that work, by definition, is FD cosine of theta, where theta is the angle between the force and the displacement. Here we have 1,100 equals the force of 30 times the displacement of 50 cosine of an unknown angle. So this would be 30 times 50 is 1,500, so we would divide by 1,500, and then we would get, let's grab our calculator here real quick, 1,100 divided by 1,500, that gives us a 0.73 repeating, equals cosine of theta. And of course, we'll just take a cosine inverse of both sides. So I'll do that real quick on the calculator. Second cosine of that answer. I'm going to check my mode. I'm in degrees, so it should be good there. I press enter. I get 42.83 repeating, or roughly theta is 42.8 degrees, which we'll find is our correct answer right there. As we go down, and let's take a look at question number 13. I really like this elephant question. I like the discussion that it allows us to think about in terms of anatomy and physiology, and also just biology of different organisms and how they utilize energy. So the question is, how fast must a 3,000 kilogram elephant move in order to have the same kinetic energy as a 65 kilogram sprinter running at 10 meters per second? So we have a speed for this elephant, or we're looking for a speed for the elephant given a speed for a sprinter. Now we know that the bigger you are, that mass, the bigger the mass is, our kinetic energy is going to be increased by the mass being so large. But we also know that velocity matters. And so when we look at this, we want the kinetic energy of the elephant to equal the kinetic energy of the sprinter. And so we look at the formulas for the kinetic energy. It's 1/2 mass, which for the elephant is 3,000, times v squared. Now we don't know the velocity of the elephant. Remember, kinetic energy, 1/2 mv squared. That's our formula we're working off of. And there's the elephant side, and then there's the sprinter side, 1/2 of 65. Now if you think about this, then the elephant is 3,000 kilograms. The sprinter is just 65 kilograms. Clearly the elephant wins in the mass department. And so it's not going to have to run as fast as a sprinter to utilize the same amount of energy. However, the sprinter is going to be moving much faster than an elephant typically would, at 10 meters a second, and that gets squared. Now, that's a big deal. When it comes to solving this, half of 3,000 is 1,500, so we're going to divide both sides by 1,500. And then we would take a square root to eliminate the square. So the velocity that the elephant is going to have to travel at in order to match the kinetic energy output of the sprinter is 0.5 times 65 times 10 squared is 100. And then I'll divide that by 1,500. And then I'll take the square root of that answer. The elephant only has to travel 1.47 meters per second. What that tells me is that this elephant doesn't have to be moving very fast in order to use a lot of energy. Because that kinetic energy that the elephant gains, or that the sprinter gains, is going to come from stored chemical bonds in their muscle tissue and in their fat and in different parts of their body where they store energy. So we're talking about this elephant not moving real quick and using just as much energy as a world-class sprinter or a sprinter who's really moving. So the point is that when we talk about metabolism and metabolic rates, these larger animals, they have to be eating all the time in order to maintain body mass. They won't be able to maintain their body structure if they aren't eating enough calories or joules of energy to supply their body. This is a real problem and challenge for animals that are large. Constant eating and producing or storing food. All right, that should be everything to get you through a couple examples. Good luck, and we'll see you in class.